Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Geometry makes up almost one-third of the test questions. Standard 8.G.9. Volume of cylinders, cones, and spheres. Solve real-world and mathematical problems involving volume of cylinders, cones, and spheres. This is the last standard in the domain of geometry.
Hello and welcome. Here is what you need to know before we get to the examples.
Cone, cylinder, and sphere.
Okay, we need to know the volumes of a cone, a cylinder, and a sphere. The formula will be given to you on the test, but it's not really that difficult to remember them. The cylinder is the base, which is a circle, times the height. The cone is base times height divided by 3, which is 1/3 of a cylinder. The sphere is 4/3 pi r cubed.
Cone
Now-
versus cylinder.
Now, the volume of a cone is 1/3 the volume of a cylinder, which means volume of a cylinder is 3 times volume of a cone when they share the base and that they have the same base and the same height. Okay, so if you have 3 cones like this, you add them up volumes, they give you the same volume as this cylinder. They have the same base and the same height.
Note.
When you compute the area of the base of a cylinder or of a cone, make sure to use the radius, not the diameter. That's where students sometimes get confused and make mistakes. So when they give you the diameter, you need to find the radius. The radius is half of the diameter. Half of the diameter is the radius. And the area of a circle, remember, is pi r squared. And pi, you can take 3.14 as an approximation for the value of the number pi.
Recommendation.
To make the most of these videos, I suggest pausing the video when you see this button, solving the problem, and then resuming the video to check your answer.
Example 1.
In this example, a cylinder is shown. What is the volume in cubic meters of the cylinder? And they are saying the level 2 here because of this issue. They are giving you here the diameter, see? So you can't use the 6. You have to use half of it, which is the radius. So the solutions, the volume is, again, base times height. Base is a circle, pi r squared times h, height. So the r is half of the diameter is 3. So you need to use 3, not 6. Now just apply here pi 3 squared times h. That's 90 pi cubic meters. You watch here, it's right here. Now, if by mistake you used 6 instead of 3, you get an answer of 360 pi, and you think, oh, it's right here, and you think that's the right answer, which is not the right answer. So be careful when they have a diameter, you need to use the radius.
Example 2.
A cylinder is shown. This is level 1 because that is direct application of the formula. So we need to find the volume in cubic centimeters of the cylinders. Round your answer to the nearest tenth. Okay, solution again. That's the rounding to the nearest tenth. Volume B, base times height, pi r squared times h. So this is the radius, we have it, and this is the height, okay? So 3.14 I use for pi, 8 squared times 6.5. You get this cubic centimeter. They want it to be rounded, so you just get rid of this 4. You get 1,306.2 cubic centimeters.
Example 3.
Again, reminder, you can pause and do the problem first. Here's a cone, and the radius is 3 here. That's, again, a direct application of the formula. Remember, when you are talking about the cone, is 1/3, 1/3. Nearest integer, where they want the answer here. 1/3 BH, 1/3 pi r squared h, 1/3 3.14 times 3 squared, because r is 3, see r is 3, times 18, the height is 18, you get this number, which is about 170 cubic inches. That's it.
Example 4.
Chandni compares two cylinders. Both cylinders have an identical base. You have to read the question carefully. Identical base, okay? The first cylinder has a height of 4 and a volume is 120. So the volume is 120 and the height is 4. The second cylinder has a height of 7. So now I identified all these numbers. What is the volume in cubic inches of the second cylinder? Now, for problems like this, it's recommended that you make small sketches really quickly. So you do this sketch, that's the base, the same as the base here, and that's the height, and that's the volume. Those are this, and this are given. So we need to find the volume of the second cylinder, okay? So first cylinder, the volume is base times height, base times height. Okay, I know that's 120 is equal to b times 4. From here, I can get b. B is 30. Okay, b is 30. Now I use it in the second cylinder. Base times height, 30 times 7, 210 cubic inches. That's it. Very simple. Very simple.
Example 5.
Nadia has a cylindrical container that stores sugar. The radius of the container's base is 5 centimeter. Radius important, and 5 centimeter. And the height of the container is 18. So that's straightforward application of the formula, right? So volume is base times height, pi r squared times h, 3.14. Radius is 5 squared. Height is 18. You get 1,413 cubic centimeters. Now, if you use a different approximation for pi, you might get this answer instead of this. Both are correct.
Example 6.
A farm has two cylindrical silos for storing grain as shown. How much greater is the volume in cubic feet of the larger silo than the smaller silo? So so you need to find the volume of each one of them and make the difference, right? Right? Okay. So the large silo, that's this one here. Volume is base times height is pi r squared times h. R is given 18, h is given 20. In this example, I'm going to leave pi alone. Okay? So you get, replace here, you get 6,480 pi. The second one, the small one, again, the same formula. 12 here I use, 12 and 30, I get 4,320 pi. The difference is 2,160 pi. Now, if you used a number for pi, you might get an answer between 6,782 and 6,789. All of these are correct answers.
Example 7.
A candle in the shape of a cylinder has the dimensions shown in inches. What is the volume? It's very straightforward here, except that you have to pay attention. He is giving you that diameter, the diameter. Don't make the mistake. Don't use the 5. So BH, base times height, pi r squared times h. What's the radius? It's 5 divided by 2 is 2.5. Put it here in the formula, 3.14 times 2.5 squared times 8, the height. You get 157 cubic inches.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.